So now we are going to learn how to use a mux to generate a logic function. It is how to implement a logic function using a mux. So in this example, the given function is f is equal to a plus x or bx or c. So you have to implement that using a mux. So there are three variables a, b, c. So the first step is to write the three variables, that is a, b and c. So I write here the variables a, b, c. Then we have to find out the function f, that f is equal to ax or bx or c. So starting from 0, 0, 0, 0, 0, 1, writing up to 1, 1, 1. The combinations of a, b, c is written. Then the function is calculated, that is ax or bx or c. So in the first row we can see 0, 0, 0. So 0 XOR 0 XOR 0, that is 0. And similarly, you can find the remaining. For example, the in-between case of 1, 0, 1, we get the value as 1 XOR 0 XOR 1, that is equal to 0. Because 1 XOR 0 is 1, and again 1 XOR 1 is 0. Then how to implement the logic function? For that, let us see. First you have to draw the mux. So since there are three variables, it is a, b, c, there should be three select lines. So three select lines means we can select 2 raised to 3. So 2 raised to 3, that's equal to 8. So 8 combinations can be selected using 3 select lines. So we are using an 8 is to 8 by 1 mux. We are selecting an 8 by 1 mux is selected. So first one is selecting the mux. So since there are three variables, we can use three select lines, and the data can be 0, 0, 0 to 1, 1, 1. So there are 8 combinations. So 8 datas are there, and depending on the select lines which you are applying, based on that we must get the output function f. So first we are drawing so there is we are selecting an 8 by 1 matrix. So the 8 by 1 matrix we are drawing like this. Then we are giving the 8 inputs starting from D0 to D7. Then the select lines are given one by one, that is A, B and C. Then only one output is there because it is an 8 by 1 mux. Now we can see the truth table. From the truth table we know the D0 value is 0. Then D1 value is 1. So we can see the D0 is for D0 the output is 0. Then D3 the output is 0. D5 and D6 the output is 0. So we can connect D3 D0, D3, D5 and D6 to 0. So this is the first step, connecting. So we will use a different color. It is D0. The values are D0, then 0, 2, 5 and 6. Sorry, 0, 3, 5 and 6. Okay, 0, 3, 5 and 6. D0, 3, 5, 6. So these pins we can connect to, depending from the table you can see the values are 0, and for the remaining values the output is 1. So for these are connected to logic 1, and the remaining values are D1, D1, D2, D4, D7. Okay. So this value we are connecting to logic 0. So first connecting D1, D1, D2, D2, D4 and D7. So these lines are all connected to logic 0, and the remaining lines, that is D0, D3, D5 and D6. This line will be connected to logic 1. So this will be the implementation of the function using a 8:1 mux.